share my screen. Okay, so here. Okay, yeah. So today's topic, everything will be on the cyber security one. Okay. So let me. Yeah, we are starting the recording. Just hold on, guys. Yeah. So we'll proceed. And so the smart grid, it's all about the conversion of the IT and OT, right? So we have the OT devices, which are the smart meters, the smart sensors, the SCADA systems, and so other physical devices which are present in the field, and all everything we are trying to interconnect via the communication protocols. Correct. So let's say now, so what are the parameters we will be converting to the digital one? One is the OT technology. So where we have the substations. Inside the substations, we have the RTUs. In the RTUs, we can have the PLCs. We can have the smart meters and everything. So this is one of the parameters which is called as the OT, where the physical parameters are measured, right? And then the OT and the cloud conversion. So we have again we have the field devices. We are trying to communicate the field devices to the cloud, where we are trying to process the complete data, right? That is one thing. And coming to the IT is where we are storing the complete database. That is the enterprise, the database where we are processing the information which we have received from the field devices, where it could be an billing application, and or else it could be an forecasting. So basically we are trying to process the data. Correct. And in this specific smart grid, it is not only the unidirectional, so it is then bidirectional, because the data in the last previous classes we have seen the data always flows from the bottom layer, that is the field layer, to the cloud, that is the upper layer, right? So the data is flowing from bottom to top, and the command will be given from the top layer to the bottom layer. So in that case, we call this as in the bidirectional communication. If you see the legacy one, it is always the unidirectional one. Correct. So the problem in this, even though we are trying to modernize this system, correct, it will come with its own risk. So the this digitalization of the data, it is very much easy for the cyber attackers to sniff in. Why? Because there are a lot of vulnerabilities. So the smart grid, it's not a single unit, correct? It will be in multiple units, and the multiple uh, microgrids are interconnected. Let's say we have these the homes, the who is having the rooftop, and these rooftops is communicating with each other within smart meters. And also we have different substations and the SCADA systems, which will be communicating either via the cables, or else through the Wi-Fi, which we already spoke. The Wi-Fi is the most vulnerable, the means of communication. Why? Because anybody can able to access that uh, RF signal. Okay, if it is in wired, so it will be a more difficult, but it is possible. But in the wireless, it is much easier, right? And when these data are moving into the cloud, again So if it is not encrypted, so we will talk about the encryption, and we will talk about the type of encryption, type of attackers, right? So if we are not encrypting these datas, so it will be very much easy for an attacker to come in and do the bad taking decision. Like, let's say he can able to switch on or switch off the breaker, and he can able to destabilize the complete system. So it is very much important that we take care of this digital network, where we call it as an smart grid. Correct. Now, so when it comes to the vulnerability, right? So there are lot of the type of it. These it is not limited to these five attacking the way. So, but these are all the main the vulnerabilities or the attackers can able to aim, right? So let's say the first one is the false data injection. So this is one of the way where the attacker, what he will be doing is he will target the integrity. Okay, when I say the integrity, it's all about the manipulating the data that is being sent from the sensor or the controller to the central system. Okay, so what will happen if we are trying to if we are not getting the actual actual data? What will happen, for example, if we have the field devices, right? Smart sensors. So this will be sending the proper the parameters. Let's say it can send the voltage, the frequency, and the so on, right? So we will be having set parameters. For an example, so voltage could be in 230 and the frequency is 50. So it is a normal operation, but if someone can able to plug into the this smart sensor, okay, the smart sensor will be having the ports, correct, RJ45 ports. So if we are not securing these ports, anybody can able to use their laptop, plug into the device, and he can able to manipulate the sensor data. Okay, so let's say if he is trying to manipulate and if he has bypassed the BDD, so we call it as an the bad data detection. So this is one of the controlling technique which will be used inside the smart meters. Okay, so when he can able to bypass this BBD algorithm, he can able to change the data sending. For example, the grid will be operating normally, or else like the system is not operating normally, but he can able to manipulate the data. For example, instead of 230, he can say 100 volts, and instead of 50 frequency, he can able to 30 hertz. Correct. So when this data is sent to the SCADA system, what it will think there is a problem in the system. Okay, and when this happens, there will be an instability in the grid, because the SCADA system is all about to make the system stable. Correct. So what it will be doing is it will try to match back to the normal state, that is 230. But in the actual scenario, the voltage and the frequency is normal, but still because of the bad data which we are receiving from the false data injection, we are taking it the wrong decisions. Correct. And also the again other problem is these SCADA is connected to our cloud, right, where we are taking all the information for the AI analytics. Correct. It is interlinked. When this manipulated sensor data goes to the AI, so what it will be doing is it will, if we are not taking any measures, then it will process the same data and it will give the forecast. So what the forecast will be telling, forecast will tell, okay, this specific device on the specific grid is having the malfunction, not malfunction, there will be a problem in this, and take the necessary action, right? So this is how the false data injection will takes place, right? And the monitoring of the system and complete, if the attacker could able to penetrate inside the different devices, it is only the one device. If we can able to penetrate to the hundreds of devices, then the complete smart grid will be a problem, correct? Yeah. So that is the one of the attacking ways, that is false data injection into the system. Okay. And coming to the second one, the man in the middle. So this is very much the famous type of attacks. Okay. So what this man in the middle attack looks like. So take this as an example. Okay. So the attacker. So there will be, the consider this as an our sensor, and we also have the smart meter 1, and think like smart meter 2, smart meter 3. Okay, these smart meters are connected to the, let's say this is connected to the HT panel, this is connected to the LT panel, LT panel, and this is connected to the transformer. Okay, and these smart meters are connected to the routers. And this router is connected to the SCADA system. Think like this is the SCADA system. Okay, right. Now, in the normal operations, what will be happening? So these sensors, smart meters, will be sending the data to the SCADA system, right? So, and every smart meters and the sensor will have the IP address, and also it will have the MAC address. So IP address is a logical address. Okay, you might have seen 192.168.6.1, for example, and this can be an 192.168.0.2, and this can be 192.3, 192.168.0.4, and the router will have one IP address. Let's take an example, dot 5, and even this SCADA server will have the IP address 192.168.6. Okay, so these IP address, we have the two types, correct, which I discussed earlier. One is the public IP, and other one is a private IP. And these IP addresses, so it should be an private address, it should not be in public. So when we configure public IP address, anybody from the internet can able to reach this specific device. So it is always, it will be and the private IP address only. Now think like the LT panel had some issues. Okay, so the sensors, the smart sensor will detect this, and it wants to communicate to the SCADA system. Okay, what it will be doing is, it will say, okay, it will ask the router, how can I reach the SCADA system? So router will have the table called ARP table. Okay, so this ARP is called as address resolution protocol. So this will have the all the MAC address of all the sensor as well as SCADA system. So this table will have the complete information about the system, and also the IP address of the respective MAC address. Correct. So when this smart sensor wants to communicate to the SCADA, it will reach out to the router and it will ask for the MAC address and this IP of the SCADA. So based on this the table, what the router will give the details of the SCADA. So now the communication will start from the sensor to the SCADA. This is a normal operation. Now let's think. So one attacker comes in and he saw some ports. So in the switches we will be having the ports, correct? So if we are not so when I say switches, it is a network switch. Let's say we have the Cisco or else like any of the other OEM switches, correct? So let's say we are not securing that switch. What will happen? So anybody with a laptop, he can able to plug into the system, or else if it has any the Wi-Fi, then still he can able to access that. So what he will do is he will just plug into the plug into the system, and he will modify this ARP table. Okay, so instead of let's say this smart meter wants to reach out to the SCADA, instead of reaching out to the SCADA, the ARP table will give the attackers MAC and IP address. Okay, so the smart meter will think, okay, this is the actual SCADA, and it will start communicating and it will give all the information. Information is like the model number, the IP address, and the parameters, variable parameters, and it can also give the parameters on the SCADA system and other devices also, right? Which is in the system. Okay, so when this happens, he can able to take the decisions, right? And let's say he can able to open open the breakers, or else he can able to shut down the system and so on. Correct. So this kind of the attacking, we have to mitigate it before it happens. Correct. If something goes wrong in any specific substation, and he can able to take down the complete substations. Correct. And the instability will increase if that happens. Right. So this is one of the way. And the third type of attack is the denial of service. So it is also known as the DDoS. Correct. So, and the latest, again, it is called as DDoS. Both are same. What this will be doing is, so it is all about the flooding the SCADA system. Okay, just take this as an example. So let's say we have the SCADA system. Correct. So consider this the SCADA system, SCADA server. Even this as a SCADA server 2. This is SCADA server 1, SCADA server 2. If we have backup servers, SCADA 3. Okay, so now think that this is our smart meter. Smart meter. Okay, so in the normal conditions, what will happen is, so this will be keep on communicating to our SCADA systems, correct? And this will be sending the details, the parameters, voltage, frequency, and so on, right? For every set parameter set time. For example, this will be sending the details every 1 minute, or else 5 minutes, or else 10 minutes. So we can able to change that based on our requirement, right? So now what attacker will be doing is, so he will just see the vulnerability, that is this SCADA systems, SCADA servers, right? So now, so what he will do is, he will open his system, the laptop, and what he will try to do is he will be sending continuous sync flood. So that is like he is trying to reach out to the SCADA system. He is sending the ping continuously, and the SCADA system, yes, the server will also respond to the system, telling that acknowledging the ping. Okay, so if it is one or two pings, then that should be okay. But what if is for a second he is sending the millions of requests, right? Per second, millions of requests. It cannot handle, the server can handle, for example, let's say the server is having the 16 GB of RAM, and also like 10 core of CPU, right? So until these resources get exhausted, so it will be responding, correct? So what will happen is, after certain time, this SCADA system will goes down. He will do the same thing for other SCADA system, the backup SCADA system, where he will be sending the sync flag, right? So again, he will be sending the millions of requests per second, and even the second SCADA system will go, and the attacker will keep on doing for the all the SCADA system. So this will go offline because all the resources have been consumed, because the attacker is using his laptop to uh, to get these resources exhausted. So when this SCADA system is not available, our smart meters, so here if you see, there are thousands of smart meters inside the field, correct? What will happen is, when it tries to register the parameters, right, it can, this this is not available, SCADA system is not available. Why? Because the attacker is continuously sending the sync flood, and because of that, the legitimate users, or else legitimate device, these smart meters can not be able to reach it, and because of that, at an specific interval of time, we are missing the details. And if something goes wrong, if it is a normal state, then fine. What if something happens in that specific time? So let's say this smart meter connected to the HT panel having some issues, and it is trying to send the signal to the SCADA system about this problem in the HT panel, correct? In that case, we cannot take the necessary action, and the complete system is designed to take the automated actions, right? So that is the biggest problem what we are having when there is an attack, that is called as DDoS attack, right? So how do we solve this problem? So now there will be an, the solution which is called DDoS prevention softwares. So what that will be doing is, so what it will be do, so we need to install that within this server. And so DDoS protection software, it will see, even the attacker laptop should have the IP address, correct? IP address. So this DDoS protection software will be monitoring everything. So let's say it will see this IP address which is not related to any of the smart devices, right? And it is also the outside the network, and it is continuously sending the sync request, and it will detect, okay. And also it will notice, because these DDoS softwares are trained based on the latest algorithms, that is AI and ML. It will always predict, and it will always see, okay, this specific address is sending too many requests, which is an anomaly. Anomaly, when I say anomaly, it's an unusual behavior, correct? So the smart meters will never send so many sync requests to the SCADA system. Immediately it will understand, okay, so this specific IP address needs to be blocked, and it will block. If the same thing the attacker tries the same thing with other SCADA system, again the connection will be blocked, right? When we, so by this, the DDoS software, we can able to secure our SCADA system infrastructure. Okay. Right. So this is how we can able to safeguard our smart grid. Okay. Any doubts till now? Okay. So let's move to the third one, that is ransomware. And this is one of the, uh, the ways. So the ransomware is like taking the control of your data and asking for the money. Correct. So let's see how the attackers will exploit the SCADA system. You consider this, okay? And let's say, let's take this. So there are a lot of types of ransomware, right? And also we call that as in malware. Okay. For example, so my SCADA system, it has been having the some database, correct? Obviously, because we need to store the data, the field device data, correct? And these the database will contain large amount of data of the field for every interval of time, correct? And this, the data is confidential for us because it should not be shared to the public network, correct? Now what attacker will be doing is, so if, let's for example, let's say you are an operator in the SCADA operator, SCADA admin you can call. So he might receive one email from the KPTC TCL telling that the PDF file is for any of the invoice for the vendor or something. So immediately what the SCADA admin will do, if he opens that specific attachment, in the attachment there will be an the software, okay, that is the ransomware or else the malware. So when he clicks on that PDF file, immediately the program will run in the background. So what this program is, this is nothing but the asymmetric encryption. Okay, that is the asymmetric encryption. So this encryption key will be with attacker. Okay, so now what he will be doing is he will encrypt the complete data with this encryption key which he will be having. So when he do this the encryption, so this complete file we cannot able to use it. Why? Because it is already encrypted and only the key it is with attacker. Now what attacker will be doing is he will say, okay, to decrypt data this data is very much important for us for the smart grid and also to run the SCADA system, right? What he will be doing is he will ask for a ransom is like in the money, he will ask for a money to decrypt. And so yes, if we are not paying the amount, then he will not decrypt it. So again there will be a problem. There is only the two solution: either you need to discard this the database and create the new one. When you do that, So the historical data which we had collected from the field devices, it is lost, right? If you have the backup system, then yes, that is fine. So that is the reason you always need to have the backup database either in the on premises, either in the substation, or else that needs to be dumped to the cloud for the archiving purpose, right? So now how do we safeguard our SCADA system? Let's say we need to have the ransomware, or else like anti-malware software. What it will be doing is any attachment or any suspicious software program starts to run, right, it will block that. Okay, so that is one thing, and that is how we can able to safeguard our SCADA systems. So the SCADA system here is very much critical because we are trying to monitor the real time data from the field devices. Correct. That is one of the type of attacks what we have. And the last one, yeah. So the last one is the insider threat. Okay. Now insider threat, it is not the attacker who is attacking the system. Instead, so let's say the SCADA system, most of the time, the configuration of the field devices or the SCADA system, it will be done by some of the vendors, correct? Contractors. So the KPTCL or else any of the electricity provider company will outsource the IT to a specific company, correct? So they will say, okay, so please integrate the substation with the SCADA system. Okay, then this the contractor, the IT contractor, what he will do is he will take the admin password, and also he will be having the access to the all the root level access, right? When I say the root level access, it's a highest admin access. He can able to do whatever so he wish to do, right? So let's say now this IT person who has installed the SCADA system and also the configured the smart meters, and the smart meters, there will be various kind of smart meters and various and there will be a number of smart meters, and he will assign the IP address to all the smart meters because they have to talk to the each other, and also they needs to talk to the SCADA system, correct? Now this the contractor or IT person, after installing everything, he he will go back, but still what he will be doing is he can have the admin password and the root level access, right? This is very much risky. Why? Because at any given of time he can able to come back, and what he can able to do is he can able to log into the any of the smart devices because he has the password and he knows the IP address of all the smart devices. He just needs to log into one of the smart device, and he can able to take out the complete information from the SCADA database. Okay, so he can able to sell this database to any competitor, or else it could be in the dark web, correct? So when this happens, so the attack, so we saw the different type of attack, correct? So these kind of attack may happen, right? So when you know the IP address, the SCADA system, what encryption we are running, and what kind of security we are maintaining inside the SCADA systems, and how the data is flowing from the SCADA system to the cloud, and what is the encryption type we are using in the SCADA system, and so on. So this is very much possible way of attack, right? So this is also known as the privileged misuse. And this kind of privilege misused, it is a long term, we cannot uh, predict, right? Because this inside threat, he is not attacking the system. Instead, he is taking out the information and selling, or else he can able to do the attack himself. So we cannot sense this. That is one of the problem we are having, correct? Okay, this is one of the problem what we have. Yeah, so how do we prevent this? So to prevent the inside threat, what we have to do is, whenever uh, the subcontractor or like IT person has configured these smart devices, correct? We need to take out the all the credentials from his from his laptop, and we have to revoke the root access. So and also we have to check the access, the root access, and only the root access should be given to the SCADA admin, and SCADA admin needs to change the password, and also he needs to always routinely check what kind of access is having to the other users. So based on the so basically what we have to check is the privileged users. So let's say we have the admin user 1, right? Admin user 1 and admin 2 and admin 3. Let's take an example. Okay, so admin 1 should have the complete privilege. He should needs to have the root access, and other admins 2 and 3, they should not have the root access, because giving the root access is giving the complete authority of the SCADA system, right? So for that reason we are not giving any root access. So these admin will have the restricted read only access to the SCADA system. Even the admin 3 will have only the read only access to the SCADA system. When we have the read only access to the SCADA system, he can only read the data from the database, and also he can able to only the monitor and take the predefined necessary actions only. Okay, so this is how we can able to reduce the privilege access, and also only the required admin can able to get the root access to the SCADA system. Okay, by doing this we are eliminating the insider threat, right? Okay, so this is the five very top the vulnerabilities and the attack type what we see in the smart grid or else SCADA systems, right? One is the false data injection, and the man in the middle, and the denial of service, and the ransomware, and the last one is the insider threat. Okay, so anyone having any doubts on this? Okay, so next we will move to the very important topic. So okay, before I start, we'll take in 5 minutes of bio break. Okay, I will be back in 5 minutes. Okay, so this is one of the important topics. Okay, so if you try to understand this concept, so you can, when you are designing any of the system, correct, the secure system, this is the basic of everything. Okay, so now we saw the type of attacks what usually we will notice in the smart grid or any of the IT infrastructure. Now, uh, let's say, how do we secure the connection between the client and server? Here, if you see the client, if you see, one second. Okay, let me select the pen. Yeah, no, it is okay. So, this is now we will talk about how we are going to secure the connection between the client. So when I say the client, it is the smart meters. Okay, think like smart meters or the sensors. Okay, and the server is the SCADA server. So this specific use case, why is required? Because so these sensors, it is spread across the network or else the wide area, correct? It is like we are having the hundreds of sensor devices, and these sensor devices has to be communicate to the central SCADA system. So you cannot be having the private connection for all these sensors, correct? It has to communicate through the internet only. So most of the cases, because as I said, it's a very vast installation is what we will be doing. Every house will have this smart sensor. Every feeder will have this smart sensor, and also we are installing smart sensor in the wind turbines and also in the solar panels, right? So because of that the constraint, we cannot lay the private the cabling to the SCADA servers. So instead of that, what we will be doing is, so internet is available either from the Wi-Fi or else like any of the service provider can able to give the connection to us, correct? For that, what we will be doing is we are trying to connect this sensor to the SCADA through the internet. And so internet is not unsafe. Why? Because if we this connection is not secure, anybody can able to take out the packets which is sending from the sensor to the SCADA. And we saw what kind of attacks can happen. The majorly the man in the middle attack will happen. Correct. So now let's go in the depth how we can able to secure the connection from the client to the server. Okay. Let's take in this one. Okay. So assume. So we have. Let me select my pen. Why it is not coming? So hold on, guys. Yeah, here it is. Yeah. So think that we are an IT person configuring the device, smart meter. Okay. And we have the server, SCADA server. Okay. This is our the SCADA server what we are having. Now, so as an IT, we just need to log in and to the smart devices for the configuration. For that, first we have to reach out to the server, correct? Through the internet. Okay. Now, so this is an get request, get, or else like you can say the put, and this connection is HTTP request, that is the hypertext transport protocol, correct? So, we are trying to register this specific smart meter with the SCADA system, okay? And we are trying to establish the connection from our laptop to the server, and the request will go through the internet, and it will be via HTTP request. That is a protocol what we will be using it. Correct. Now the server, what it will ask is, okay, we are trying to register the smart meter. It will ask for the this credential of this specific person, and what this guy will be doing is he will send the identification, or else we can say the credentials, correct? The passwords. The credential is what he will send. And the problem with this is now, if we have any person sitting here, so this the credential is in the plain text, okay? And if this is an attacker, he can able to simply grab this packets which is traveling from the the client end device to the SCADA over the internet, and that is also HTTP, which is not secure one, correct? So what this attacker will do is it will gain the access to the credentials, and he can able to log into the SCADA system if he has these credentials, correct? Once he log into the SCADA system, he can able to do various activities the so installing the misinformation, or else making the breaker to open, or else making the breaker to the close, or else manipulating the data which is connected to this SCADA system, correct? That is database. So this is the problem. Now how do we secure my connections, and how do we save the credential which is transporting through the HTTP? So the one way of doing is so encrypting this, correct? So how do we encrypt this? So let me clean this. So let me, okay, yeah, yeah. So we cannot simply send this the credentials in the plain text, correct? So instead of that, what we will be doing is, so we will create one key that is called the encryption key. So from this encryption key, so we will be encrypting the credentials, and then this encrypted credentials will be transported to the server. So again there is a problem. So once this credential is received in the server, so the server also needs to have the key to decrypt back these credentials, correct? So after sending these encrypted credentials to the server in the separate packet, the user will be sending this the key to the SCADA server, so that he can that server can able to decrypt the credential. Again, the problem here is the attacker, if he can able to capture that specific the packet which is taking this the key, correct. So again, he will be having the key, and he can able to decrypt the credentials. Okay. However, the credentials will be sent to the SCADA system within different packets. Okay. If attacker could able to sniff it, then he will be having the credentials, and the keys will be transferred to the SCADA system with a different packet. If attacker could able to get the sniff it this keys, then now the attacker will have the both the keys as well as the credentials. Correct. So again, there is a problem, and this is one of the possibility where if attacker is the smart enough to sniff the packets, then he can able to get the both the keys as well as credentials. So now again, how do we secure it, right? Let me wipe this out. Till now, anyone has any questions? Okay.
No, sir.
So now let's so now again, let me draw this. Okay. So instead of we creating only single key, so what we will be doing is, so initially when I say in the last example, that was called as symmetric encryption. Symmetric encryption. When we call it as symmetric encryption, because we are using the same key to encrypt as well as same key in the server side to decrypt. Correct. So it's in same the keys what we are using it. So in that case, it is all about the symmetric encryption. So now we saw the symmetric encryption is also not secure. So what we will be doing is the latest one. It is all about the generating the two keys. Okay, instead of one. Okay. Okay. So in the client, so the client will be generating the two keys, that is called as, one is called as public key and other one is an private key. Okay. Now similar way, we are trying to configure the smart meters, and before that we are trying to establish the communication. Now the credentials have been will be actually will be encrypted by using these keys. Okay. The private key, the initially the encrypted credentials will be sent to the server, and also after that we will be sending the private key, and again the public key will be sent after by encrypting this by using the private key, so that this the SCADA can able to decrypt back the credentials, and the login details can be given to the this this person for the configuration of the smart meters. Correct. So this is one of the way we can able to do it, but before that, like these these keys can be generated by using open SSL or something. Okay, that is one thing, and the problem again here is, so if the hacker is smart enough to capture the both the public and the private keys, again there is a problem, because we are sending the encrypted data, and even the server will be having the private key, right? So if we can able to, whenever the packet is traveling, if we can able to get this data, both the public and the private key, again he can able to log in. So there is an problem, because like it is not secure, it is an http request. So when we have the https, that is the secured one. For example, uh, if you open any of the browser you are having, correct, and if you are trying to establish the connection to any of the server, you can able to see this green, correct, one lock will appear like this. When you have this lock, that means it is insecure, that is an https. If it is not lock appear in the web browser, then it is an unsecured connection what we are having, correct. That is one thing. So in the second scenario, what will happen is, so we are trying to generate the keys for both the server as well as the user. Even the server will be having the private key as well as the public key, and these private and the public key will be exchanged between these two, and the encryption will happen. Okay, this is one of the way. Now the latest the way of securing is, so instead of this public and private key, right, so here we are sending the public and private keys to the server, and the server will be decrypting and encrypting. And it is possible the attacker can able to sniff this the packets and can able to catch hold of the public and private key. Now the latest the way of securing this connection is by using the certificates, right. So this is very key concept. Let me, and this is also called as SSL or TSL connection. Okay, yeah. Okay, let me pull my pen. So till now we saw how the private and public key will place a role in the decrypting and encrypting the credential, correct, and this is called as SSL or T. Okay, this is secure socket layer and the transport layer security. This has been obsolete because it's kind of old technology, right, and we are running on the TLS, that is the latest is 1.2 or 1.3. Okay, so this is what we will be looking the transport layer security, right. So now imagine, so we have so let me grab my pen where it is. Yeah. Okay, here we have the concept called CA, that is the certificate. And so what this certificate will have, certificate, we will be issuing the certificate to all the devices, smart devices in the field. Okay, and also the certificate will be installed in the server. What is this certificate? The certificate will have the complete information about the server, and certificate it is issued by either, if we have internal if this is an internal network, then internal certificate server we can able to have, where we can create our own certificate, where we define what kind of SCADA server it is, and the complete IT information will be having, and this also will have the public key, right, and this will be installed in the server. And the similar fashion, we can able to generate the certificate and install it for in the every smart meters and the sensors. right here and also here. Now, so if this is a public connection, then we have to buy it from the, so let's say we have Symantec, also we have a DigiCert. So these are all the CA issuing authority, correct? So what they will be doing is they will issue the certificate if we request them, and these certificate can be installed in the server. And whenever we open an laptop within browser, correct, so the browser also will install this CA, that is the publicly available, and it will authenticate the authenticity of the server, because this browser will have the all the certificates, and this certificate will just cross reference the certificate of the server, right? If this feels legitimate, then only the connection will establish. If not, the connection will not establish. So, and in the similar way, if we are installing the CA, that is the certificate in the smart meters, the smart meters, when it tries to communicate to the server or the internet, right? So the server will check the authenticity of the CA. So certificate authority also will have the expiry date, and it also have the details like to which network it belongs and what is the complete IT information is what this carries. Once this CA comes to this, the server will cross reference this CA, and then if it is the legitimate sensor, then only this sensor will be added to the system, and this can able to communicate and send the parameters, the voltage and the frequency and so on, right? So once this the certificate is authenticated, it can easily can able to send the data to the servers. Okay, clear? So for example, if some attackers comes in and he logs in, and if he tries to, you know, establish a connection, right, or else if he tries to install an the certificate which is not authorized, what it will do is, even though if we can able to establish the communication, the server will check the certificate, right? Certificate will not match. So when the certificate will not match, in that case, this the device, that is smart device, will not be onboarded, so it will be taken out from the grid. So in that case, so this will be isolated, and so we can able to reduce the attack surface, right? So this is how the secure connection from the field devices, that is sensor devices, will be established to the SCADA server. So everything will happen over the HTTPS request, not the not the HTTP, right? So this is all about how we can able to establish and secure connection from the field devices to the SCADA servers. So anybody having any questions? Okay, so yeah, so I will just brief once again, because this is very important topic, and this is not only for the, you know, SCADA devices and the field sensors, right? This is also related to any of the applications we are trying to reach out. Let's say if you are trying to reach out to any of the cloud services, correct, first you need to establish the secure connection. So to do that, so it is, as I said before, it is all about the transport layer security, TLS. And so 1.2, the latest version is 1.3, which is in secured transport layer security, right? So so when we are trying to configure the smart devices, we need to send the client hello to the SCADA server, and then SCADA server will send back the hello request to the client, right? And then CA will be verified by using the public keys. It will verify whether it has been the certificate which will be installed in the smart meters. So it will check, and it will also check who has issued the certificate, and this will be issued for the specific domain, correct? Let's say the KPTCL or BESCOM or MESCOM, the certificate will be issued in their domain name. So domain name is that the owner, they are called as the domains. So we have to register our domain name to the CA, and the CA will be issuing the certificate in the domain for the domain name. Once they receive this, so the server will authenticate, and then the secret will be shared between the smart devices, or else like the laptop to the servers, right? And once everything is finished, the keys exchange of the keys will happen, and the encryption will be done, and the secure tunnel will be established. So this is how we are securing the connections between the client and the server. So basically here, from the sensor to the server, and this will be through the internet. Okay, right. Yeah. So let's talk a little bit about the symmetric encryption and asymmetric encryption, right? While in the last slide I was talking about, we will be having the two keys, right? One is the public and the private keys. So public and the private keys. So asymmetric keys is like we are having the two different keys, correct? So that is one, the public and the private key. And so w- if we want to decrypt any packets from the field devices which is traveling to the SCADA system, we need to have these keys separately. And if we don't have any these keys, then we cannot able to decrypt one thing. And coming to the the trade-off, that is, it is little expensive, because we need it requires more computational cost, right? This is one thing. And coming to the symmetric encryption, in the symmetric encryption we are using the same key for the encryption as well as decryption, right? So this is like higher efficiency and it has the low latency, but when it comes to the security part, it is very less, right? And so when it comes to the latency, so it is all about the number of handshakes what we have, because the server and the field device needs to talk to each other many times before establishing a secure connection, right? So it takes some time, so we have to make sure that the connection speed is very much reliable, and also speed, so that the latency is very less, and the efficiency is obviously it is more. And so we whenever we design the smart grid or the configuration of the SCADA system, right? So we should never use the SSL. So I mentioned earlier, this SSL, that is secure socket layer, it is obsolete. So we are not utilizing this connection anymore. So what we are using is the TLS 1.2, and even the TLS 1.0, it is not recommended. It is always 1.2 or else 1.3 version of the secure, I mean TLS. Okay, yeah. So yes, so in the symmetric encryption, AES 128 or else 256 is what it will be. We are using to generate the key and encrypt, right? And it is fast and has the low overhead, and it is very much easy to decrypt because we are using the same keys, right? And make sure that you remember this, because this is the AES 128 or 256. The latest one is 256. This is the algorithm. And if you see any of the cyber security connections, right? The protocols, the secure connections. This is what the algorithms we will be using it. So make sure that you remember these parameters, correct? And coming to the asymmetric encryption, so RSA, this is the modern technology, and ECS is very advanced one. In the so you just remember these terms, the RSA and ECC, and this is where we are using the both the private key and the public key, right? So we are using two different keys to encrypt and decrypt the packets and make sure that we are securely connecting to the server. Okay, so this is all about the encryption. Yeah, so I was mentioning about the certificate authority, right? So you can able to see we have different devices which is connected to the various equipments. It could be an the transformer, it could be an HT panel, LT panel, and so on. So every device will have one certificate CA. Okay, and this will be so these anyhow these device will be connected to these the main devices, correct? So the root to CA, that is, so we will be having the database of the certificates, right? So root CA, it is the authority where it will always check the authenticity of these certificate which has been issued, correct? And we saw how these certificate will be validated. So all the certificate will be validated for their you know details, who has issued that certificate, is the certificate is expired or not. And remember this, these certificate will be issued for 13 months only. Okay, so after 13 months we need to renew the certificates. So this is very much critical. If we are not renewing this certificate after 13 months, right, so these devices will be marked as non-compliant. Non-compliant. So sometimes the SCADA server, if we are trying to establish the connection to the SCADA servers, right, so the SCADA server, it may reject this connection. Okay, so if we don't have this connection established, then the parameters which will be sensed by these sensor devices will not be registered in the database, and this may cause the problem. Because if we are having some issues in the breaker or like any fault occurs, right, this that kind of event will not be registered, and at a specific time, at an given time, the necessary action will not be happen. Because of that, there could be an bigger trouble for the grid, right? So we have to make sure that these certificates are being renewed every 13 months. Okay, so this is one thing. Okay, and so basically you see the complexity. So initially, if you see the legacy system, we don't have to worry about these certificates, right? So and it is all about hardware connection. So we you will be having some circuit control circuits, and also the power circuit, it will be connecting to the transformer or else like HT panels, right? And everything will works fine, but we are not getting the real time information about the equipments. So now we are trying to do the digitalization, smart grid. So this is inevitable. You have to convert everything to the digital. From the digital, we get its own challenges. As I said, these CS, correct? So this is one of the challenge what we face it, right? Okay. Now the again one of the concept. So if you see here, hold on. Yeah. So now this is the stack, right? So now we have secured. So if you remember in the second class, I was talking about the OSI model, right? So OSI model. So we have application layer, application layer. We have a transport layer. We have a network layer. We have a data link layer, right? So till now, this CA and HTTP request. So we are trying to secure the application layer, correct? Now we said, okay, the application layer is secured and my complete information which is transmitting from my device to the SCADA in the application layer is secured. Now, again, we have to secure our connection in the transport layer, right? So how do we do that? So this is also one of the critical concept, right? So let's talk about how we are going to secure the data in the transport layer. To let's say we have then field devices, smart meters in the area number one. In area number two, we have another smart meter. Okay. In area number three, we have the another smart meters, and we have a substation, or else let's call this as an control station. Okay, control station where we have the centralized SCADA system. Okay. Now this device has to communicate to the SCADA system. In the SCADA system, we have the router, and as this smart meters are spread across the area and across the city, it has to be connected to the internet via internet, correct? So for that, we need some router. These are all called as edge routers, and this will be traveling through the internet. Okay. Now previously we have secured our application layer. Now we will secure this connection from the router to router. Okay. Now, so assume uh, we have this one of the specific smart meter in the area number three is trying to send the date the parameters like the voltage or frequency to the SCADA system, right? So it will be reaching out to the router, and router will have the routing table. It will say how to reach this specific SCADA server. It will give the IP address, and this smart meters we can able to reach the SCADA. Now, if it is not secure, then again in the same scenario we can have the man in the middle. So now he can able to hijack the network part. Correct. Anyhow, we have encrypted the data in the application, but he can give the trouble in terms of networking part. Correct. So to avoid that, what we will be doing is we are using the IPsec tunneling. So you might have heard about the concept of VPN, correct? So what the VPN will do is it will establish the secure connection from the endpoint to the server, right? So this is what the IPsec connection from the one router to the other router. So this is again, it is an encrypted tunnel. So think like it's a secured connection from the smart meter area to the SCADA system. Okay. So now when there is lot of the parameters involved when we try to establish an IPsec tunnel between the routers. One is, we call it as an ESP, okay, encapsulating the security payload. So what this will be doing is, this will provide the encryption, authentication, and also the data integration, right? So this is one of the parameters. And other one is, inside this IPsec, we will be having the AH, that is the authentication header. So this only provides the authentication and the integrity, right? And this will not provide any of the encryption, but it will only provide the authentication and integrity. Now the third part on this IPsec is the IKE. This is the key, okay. So this is internet key exchange. This is what the very much important parameters. So what this will be doing is, so this IKE, it always exchanges the security, the security association. This is similar fashion where we saw the TLS and SSL, right? Where we there will be an handshake. So the client will send the hello packets, and then the server will send the response back. In the similar way, here the routers will talk to each other, and they will negotiate the encryption keys. Again, here encryption keys, and the both will agree for the specific parameters. They will negotiate, and there will be some handshake. The secure connection will establish, right? And once this secure connection is established between the router in the SCADA, then after that only the packets from the smart meters will be sent to the SCADA system. So now you see, so we have encrypted our packet in the application layer. It is secured, and we are establishing a secure connection between the smart meter and SCADA router. Correct. So see the security level now. So even though if some hacker is trying to get into the network, so he cannot able to get into the network. Why? Because the complete network, even though we are using the internet to communicate, right? So it is an secured connection between the routers, right? So he cannot able to penetrate uh, this IPsec tunnel, one thing. And if he tries to penetrate by using this smart meter, there also what we have done is, we are using the encrypted in terms of the application layer, correct? So we are securing our connection as well as the packets, the data, okay. So this is how we are going to safeguard our complete smart grid infrastructure from the cyber security one, right? So when and also one more concept here is like the tampering part. So here in the IPsec tunnel, we can able to see that the packet which has been sent from the smart meter, it is the same when we are receiving at the SCADA system, right? So this is all we can able to do it by using the data integrity, right? So we will be putting some hash value. You don't have to worry about it. So this is one of the concept called as data integrity, where we will be checking that whether the data is what the actual data which has been sent from the smart meters to the SCADA. Okay. Yeah. So this is all about securing and the cyber security one. So anyone has any questions? the concepts are clear. So
Yes,
this
sir.
is this is the very critical. This is not only for your smart grid or the SCADA system. This is for any of the IT. This is the basic. Okay, and this will also applicable for your home connections also, right? So if you open any of the browser and try to connect to any server, you will, if you are like curious, you can able to open how the background the, uh, the packets are going. You can able to use the Wireshark. That is one of the tool. Okay, so you can able to capture the packets which is going from your laptop to the server, and you can able to see what exactly happening, and how this handshake, I was discussing about the handshakes, correct, you can able to see. So this is one thing. And yeah, uh, we spoke about cyber security and type of attacks, and how we can able to secure the connection application layer, and this and this. Okay, and this is another important topic, that is the blockchain. We'll do one thing, as this is an fresh topic. We'll break for our breakfast, and we'll come back at 9. Okay, and this is also one of the key important concept in the smart grid. So this is, we will talk about the blockchain, and we will talk about how the blockchain is utilized in the latest micro grid technology, right? And how we can able to sell our generated power to the other consumers. So we'll talk about this. Okay, so for now we'll break for our breakfast, and we'll come back after 9. Okay, thank you.
Thank you, sir.
Echo, echo, light off, echo, echo, volume 3.
ಮತ್ತು ಆದ್ರೂ ಕೂಡ ಒಂದು ಚುಟ್ಟಿಗೆ ಉಪ್ಪು ಉಂಟಾದಂಗಿದೆ ಅಲ್ವಾ? ನಾನು ಕಮ್ಮಿನೇ ಹಾಕಿದ್ದೀನಿ ಕೂಡ ಉಪ್ಪಿಟ್ಟಿಗೆ ಸೊಪ್ಪಿಗೆ ಮಾತ್ರ ಕಮ್ಮಿ ಹಾಕ್ಬೇಕಂತೆ. ಅದೇ ಕಾಫಿ ಬಿಸಿ ಮಾಡ್ಲಾ ಬೆಳಿಗ್ಗೆ ಇದು ಮಾಡಿರೋದ?
ಒಂದು ಸ್ವಲ್ಪ ಅದ್ರ ಮೇಲೆ ಹಾಕ್ಕೊಡ್ತೀನಿ ಆಯ್ತಾ. Okay, so we'll wait for another 2 3 minutes. Okay, then we'll start. Okay, so we'll do one thing. We'll wait for another 1 or 2 minutes. Okay, then we'll start. Okay, next 1 minute we'll start. Okay. Okay, so we'll do one thing. We'll start. I think, yeah. Okay. Okay. Now it's completely new concept. So we will talk about the blockchain. Okay. So what we'll do is we'll talk about the why the blockchain is required, what is the architectural components, sorry, the architectural component of the blockchain. Okay, so now, so just try to understand the concept here. Okay, so the blockchain, if you see the legacy one, so it's all about the centralized. database. Correct. It's a ledger. You think like a ledger, and whatever we are generating or consuming the resources, right? So everything was recorded, but it was in a single place. So this was okay if we are having a very less number of the consumers or else like producers, right? But now in the case of smart grid and the micro grids, right, there is lot of the small the units or the solar panels, like it is not centralized, it's a decentralized way, right? So when in that case we cannot use the centralized the ledger, or else we call it as a database, correct? Because we are increasing the sensors, the smart meters, everything is sending the data, and the data will be in very in terms of gigabytes, or it could reach up to the petabytes data, right? And the handling that kind of the traffic and that kind of the data, it will be overwhelmed for the system. And also it should be on the real time. So that was the very much the bottleneck what we call, right? And also if it is in centralized uh, design, if this goes down, then entire system, the ecosystem will goes down, right? That is called as the single point of failure. How do we do that? Now how do we tackle this, the problem, the bottleneck and single point of failure, right? So in for that, what we are doing is we are utilizing the blockchain, right? What is blockchain? So even though we have the rooftop solar, EV charging, the peer-to-peer trading, centralized everything, right? So every transaction, every detail, every produced the power, it will be registered in the centralized, not centralized, decentralized ledger. So everything will have its own node within the grid, okay? And this node will have the copy of all the parameters, all the generated the power and the voltage, current, and etc., right? So it is not centralized. Even though if one fails, we will be having the copy in the other node. So that one is here, we are reducing the latency and we are reducing the dependency. Now let's see what exactly the blockchain, how it works. Correct. So, and coming to before that, yeah. So before that, this the blockchain. Let me. Where is this? Okay. So the blockchain will have the three stages. One is, let me write down. Yeah, here it is. One is it is a distributed ledger, correct? So as I mentioned, so everything will be recorded. For example, if there is an rooftop solar panel which is generating the watt, correct? So it is also recorded every minute, okay? And this will be recorded in the two different nodes, so that for the high availability, if one node get fail, the other one will pick up, right? That is one thing. And the second one is the smart contracts. So what is this? The smart contracts are the self-executing scripts. Okay. So these are the scripts. It will be stored in the blockchain. That is a framework, correct? And that will trigger the action when the predefined conditions are met. Let's say, for example, so we are having the surplus energy which has been generated in my rooftop solar, right? So instead of we manually doing it, the smart contract, what it will be doing is it will execute the trade. Let's say the surplus, the power what we have generated, it will be sold to the consumer who will be in the demand, correct? And the pricing, everything will be automated. So we don't have to manually check or manually execute these orders. So the smart contract within the blockchain will execute the predefined when the predefined value is increased. Correct. That is one thing. And the third pillar what we are having is consonance mechanism. So what it is like this is kind of protocol which is used to achieve the agreement on the state of the ledger, right? Let's say this will help in to provide the proof of authority. Okay, or else we also call it as and the proof of state. So this will always validate the verify the consumer, also the producer, right? So whenever we try to sell the power which we have generated by using the rooftop solar, right? So we need to verify ourselves, and also we need to verify the consumer who will be buying from us. So this this mechanism, that is consensus mechanism, will help us doing that by providing the proof of authority, or else we also call it as a proof of state. Correct. That is one thing. And let me the last pillar what we are having in the blockchain is the cryptographic identity. This is the fourth pillar, that is the cryptographic identity. Okay, so this, the name suggests, right, the identity. So what this will be doing is every asset, that is it could be a smart meter, the solar inverter, or it could be an EV charger, right? And also the participants, the users and the consumers and the producers, right? So everybody will have one unique key that is called as the public key infrastructure, which we also call it as PKI. This is the unique the number you think like an the number. So it will be assigned to every smart meters, every smart devices within the smart grid, correct? So what it will help us is like it will help us in identifying, authenticating, right? And also it will help us where we are selling the power, and the consumer is paying us, right? So there will be a transaction, digital transaction. So everything will be based on this, the identification, that is the PKI. Okay, so the block chain will have the four pillars, right? The it is a distributed ledger, as name suggests, ledger. Everything will be recorded here, and in the blockchain, it is not centralized. It will be undistributed, and we have the different nodes. Okay, P2P. That is the P2P means the peer to peer. So, and the second pillar is smart contract. So this is self-executable script what we use in the blockchain. So based on the certain parameters, the set parameters, this will automatically execute. And we have the proof of authority where it helps us in validating the transactions, right? And also we have a cryptographic identity. This is a digital identification for all the devices within the smart grid, as well as the consumers and producers, right? This is the very architectural level of the blockchain. Okay, now let's see the use cases. So we got to know like what exactly the blockchain is and what are the pillars, right? Now the the use cases, let's say uh, initially I was mentioning about the rooftop, correct? So here three main use cases what we can able to think of, right? One is the P2P energy trading. One is P2P is like peer to peer. So here this is the producer for now who is producing the power by using the rooftop solar. Now, in the backing days, what was the scenario? We have to pump to the grid. There will be the connection from the grid. The consumer will be accessing it. Correct. That is one of the way to sell the power. But in the blockchain, so this will operate in the different manner. So we the producer or else prosumers is what we call. Basically, we are the producers. So the excess energy we can directly sell to the consumers. So we don't have to go through the grid and then then pump back to the consumers. No. So what the block this is the beauty of the blockchain. The blockchain enables the producers to sell the excess energy directly to the neighbor rather than selling it to the grid. And also we may get the good pricing for this. Okay. And when this happens, the smart contract which we discussed in the architecture, right? The smart contract will fetch the real time market price. The smart contract will always will. For example, for the 1 unit of power, it could be on 13 rupees, right? And so the smart contract will pull this rate. This is just an example. Pull this rate, and so what it will be doing is either we can agree whether to sell for in 13 rupees or less than 13, that is um, 11 rupees. Based on that, the offer will be rolled out. And so these transaction, everything is based on the digital token. Okay. Once this is validated, so this is entered into the ledger. So ledger is immutable. Okay. So when I say immutable, even though if we are entering some data in the ledger, you cannot delete it or you cannot modify it. Only thing is you can append it in the sense you can just add or on top of that. So this historical data you cannot delete, only you can able to add it. So so what is the use here? So this will be used for run. Let's say you want to do the auditing. Correct. So when you want to do the auditing, you need to have all the historical data, historical transactions, right? So for that reason, the ledger, the blockchain ledger, it is an immutable. And also second part is like it prevents the tampering. So for example, if somebody is offering at a price of 13 rupees per unit, okay, just assume. And if this is mutable ledger, like anybody can go and change this 13 to 12 or else like whatever the details they want. Correct. So in that case, complete the calculation and auditing will be a problem. So for that reason, the blockchain, it is only it is the immutable ledger. Correct. So that we get the automated and the transparent log. Okay. And we can able to get the details like monthly. And also if you want to have the real time the transaction, we can have that visibility here, right? And and the second part is the data, the meter data integrity. Correct. So for example, if we have the smart meter installed, okay, the smart meters, it is susceptible to the cyber attacks. Correct. And it is not only the cyber attacks what we have to worry, we also have to worry about the physical tampering. So when I say the physical tampering, these smart meters will have the ports and so some the mechanical device inside that, right? So sometimes these meters can be tampered to give the different readings. Correct. So how do we know that this specific smart meter has been tampered or not? So because we are storing every historical data in the ledger, and the ledger can able to analyze if something the tampering is happening or else some suspicious the output we get it from the smart devices, right? Now this will help in auditing as well as fraud detection. Correct. So this is the one of the use case of the blockchain. Okay. So I will just repeat once again. So this blockchain will help in registering all the data in the immutable ledger, so that it will help in auditing, and also we can able to see the integrity of the smart meters, and also we can able to do the fraud detection. Okay. And the third use case is we can able to generate the REC, that is renewable energy certificate. So think like every unit of power generated, we can able to get the certificate in the sense telling that this has been generated from this specific the utility, or else like specific microgrid, and everything will be registered. So if you go back and if you want to trail back and check what exactly this the power, where exactly it has been generated and who has consumed everything, the traceability will be increased. And also the second part of this is we are eliminating the double counting. Okay. So once the sold, it is always sold, the power is sold to the consumers. So this is all about the blockchain architecture and the use case. Okay. So any questions in this? This pretty much straightforward. Okay. The basically we are putting all the records in a decentralized manner, and every transaction, every generation of the units, it will be recorded, and also every meter recordings will be recorded, and this will be used in the auditing and the fraud detection. Okay, this is why the blockchain framework will be utilized, especially in the smart grid technology and also in the micro grid services. Okay, any questions? Okay. So now again, so in your syllabus we have to utilize the AI, right? Artificial intelligence. Now, how do we implement the artificial intelligence in this smart grid? Okay, and also let's say if you see this graph, right? This is the 0 day attack. So you need to know what exactly the 0 day attack is, right? So, for example, if we are running an SCADA system, okay, and this SCADA system will release uh, one software version. Let's take an example. So we are running on the software version 1.0. Okay, and suddenly the software, the new SCADA software will be released, that is 2.0. So the attackers, what they will be doing is most of the time they will be looking after the new releases. Okay, and they might find some the flaws, or else we call it as a hole in the specific code. Correct, because this is this is a newer version of the software, and it has been not intensively used by the customers, and we don't know the much vulnerability associated with this version of the software. Correct. So attackers, they always target these softwares, and they can able to find the undiscovered flaws in the code. Okay, so that is the 0 day vulnerability. Okay, now in the similar way we have 0 day exploit. So you can see here. So the 0 day exploit is like the what attacker will be doing is once he found out that there is an the flaws in the software, he will exploit that uh, the flaws, the bug in the code. So what he can able to do is he can able to log into the system, or like it could be an anything, right? So the exploitation of these flaws is called as zero day exploitation. And the third part is zero day attack. So this is where the attacker will exploit the vulnerability within the software, and then he can able to compromise the system. He can able to steal the data, or else he can able to install the vulnerability and take down the complete smart grid infrastructure. Correct? So how do we mitigate this? So to do that, we are utilizing the AI driven detection. So what exactly is this? So if you see here, so previous to this, it was all about the rule based system. So it is rule based is like we will be having certain set of rules only. Only when these rules are met, then only certain actions will be taken, correct? And if you see the duration, it was very much larger. And the exploitation, if you see the graph, the exploitation is much higher when it comes to the rule based system. But in the latest technologies, what we are having is we have this AI driven detection, where we are feeding all the anomalies to this AI ML machine learning algorithms. And what they will be doing is they will see if there is any suspicious activity or not. So and if we are using the AI driven detection, we have the higher success rate, right? So one is that, and also it is faster way to detect the problem, right? Zero day attacks. So this is one thing what we have. Okay. And yeah, so there are like the algorithms for the deep learning. So these are all the algorithms. One is LSTM, the long short-term memory algorithms. So so this is basically used for the anomaly detection, right? And also we have the CNN and the autoencoders. I will not be going the depth because so this is not relevant, but you should know how the deep learning architecture works and what are the options we are having in the deep learning as an architecture, correct? And also the model. So coming to the workflow, so let's only understand this part. Okay. So workflow, when it comes to the workflow, it is the data ingestion. Data ingestion is the where we are collecting the data, and the feature extraction. We are extracting the feature, then model. So basically, we are feeding the data, and then model will be predicting, and it will give the threat score, right? So 1 to 10 we have the scale. Usually if you see any of the industry, so we will be having the threat score. It could be 1 to 10. So more the threat score, the higher degree of the risk, and we have to act swiftly. That is one thing. And so this can be automated, so that this algorithm which they find this vulnerability, right? So what they will be doing is they can able to take the responses. Yeah. So yes, we can able to detect the anomaly detection, the predictive threat modeling, the false alarm. The false alarm is like even though system is working fine, but still the sensor are throwing some error and it is giving the wrong data. So how do we detect that? So based on the deep learning models feeding the all information real time as well as the historical data, so these alarms can be mitigated. And also we can able to analyze the behavior analysis, right? So it could be an the insider threat. So we saw previously, right, the type of attacks what we may see in the smart grid. It could be an one of the attack is the insider attacks, where where someone steals the credentials or someone having the admin access, right? He is trying to log in on a specific off peak time, and these kind of behavior
the humans cannot detect, correct? So we are trying to utilize the machine, and also inside the machine we are trying to utilize by using the deep learning technology. Okay, so this is what the action we can able to take it from by using the AI. Yeah, so this is very high level, where we not only have to secure the physical infrastructure, we also needs to secure the digital, that is the cyber security what we have to install. We are adopting the AI driven detection and the auto responses, and also we have the continuous monitoring. We also implement the encryption for the data at rest and the transit. So when I say the at rest, so I was mentioning about the SCADA with the database, correct? The database, we cannot store the plain data, it has to be encrypted. Again, to do the encryption we use the encryption keys, and so that if someone get the access to that data, they cannot use that, right? So that is the data encryption at the rest. And the transit, so transit we spoke, right? So how we are going to secure the connection from the routers to routers and in the application layer. So that is all about the encryption at the transit. And yeah, so network segmentations, so physical and the network segmentations we have to take care. So this is all about how we are going to safeguard our smart grid, the microgrids and the SCADA system when it comes to the cyber security, right? Yeah. So, in the last, whatever we spoke today, what are the key takeaways? So, securing the future grid. One
One
is
is
the
the
high
high
value
value
target.
target.
So,
So
the
the
breach
breach
risk,
risk,
national
national
security,
security,
and
and
the
the
physical
physical
safety,
safety.
right? So, we are moving towards the digital world. Okay, and when some breaches happens, it is the national threat, right? Somebody can able to do the more damage to the system and to the economy. That is one thing. And the foundation of trust. So the encryption and EKS are non-negotiable whenever you design a system or implement any SCADA system, right? You have to make sure that all the systems what we spoke about at the rest and the transit, the data needs to be encrypted. And we have to do the decentralized security, that is we need to use the blockchain, the framework, which is very much essential for the peer-to-peer energy market. So in the coming future, this is what the future looks like, where we will be as a producer and we can able to directly sell to the customer. So the decentralizing and the noting all the parameters generated in the ledger is very very important. And the cognitive layer, that is, so the AI will be implemented in all the stages. So here we spoke about the zero day threats, right? It is not only the zero day threats, but if you want to see any anomalies in the system, we have to implement the artificial intelligence. And the last point is the holistic scope. So security is not only for the specific the communication, it is for the device, the network and the cloud. So complete from the field devices to the cloud, we have to maintain the security. Okay, this is all about security and the encryption. As per your syllabus, we have covered type of securities, type of encryptions, and also the implementation of artificial intelligence. So that's it for the today's class. So if anyone has any doubts, then let me know. Okay. So from Monday onwards, we'll start the practical, and we have one more thing called as case study. Okay. Before moving into the case study, we will start the AWS, and I will be starting with the basics of the AWS, and we will design a system and we will implement it. Okay. Yeah, if you guys have no questions, then we can drop off. Okay, thank you guys.